Hi, I'm Henry Segerman. If you've ever tried to make a sphere in Minecraft, you'll know that it's not so easy. The cubic grid doesn't play that nicely with the curvature of a sphere, and so you need to make it pretty big if you want it to look any good. What you're seeing on screen are all of the approximations to spheres that you can make on a cubic lattice, where the center of the sphere is at the center of one of the cubes. We are zooming out away from the sphere so that it stays the same size on screen. Alternatively, if you prefer, the sphere stays the same size, but the cubes are shrinking. The side length of the cubes is inversely proportional to the time since we started the animation. This visualization runs in real time on the graphics card. You can check it out at shadertoy.com, link in the description. ShaderToy is an amazing website for learning how to code shaders. The code for every shader is listed next to the animation, so you can easily play with examples and see how they work. I wrote this shader to try to answer a question Ravi Vakil asked me. He saw this huge Lego globe at Legoland, California, and noticed the strikingly visible circles all over it. The circles in the coordinate directions of the Lego blocks are unsurprising. These are like contours on the map of a round hill. You expect to see circles there. But it also looks like there are circles midway between the coordinate axes and in other directions as well. So, why are there circles? In which directions do they appear? And why those directions? First of all, on the Lego globe, the sides of the bricks facing in different directions are shaded differently depending on where the light is coming from. Here in the animation, I've colored the faces of the cubes red, green, and blue, depending on the direction they face. This then gives the same effect as for the Lego globe, but it's easier to see since the different directions are given very different colors. Near a coordinate axis, say this one, the color we mostly see is green, since most outer faces of the cubes point in the green direction. If the cubes kept showing us their green sides as we went outwards from the coordinate axis, then they would be making a vertical plane tangent to the sphere. But the cubes are on the sphere, so they have to start stepping away from the plane at some point. Where the cubes step away from the plane, we see their red and blue sides. These red and blue sides disrupt the otherwise fixed green coloring, and so show us the corresponding contour circles. Halfway between the coordinate axes, say here, we don't see a single color as the default pattern. Instead, the default pattern is stripes of green and blue. Again, this pattern must stop at some point as the sphere curves away from a tangent plane. Where it does, we again see a disruption in the pattern of stripes, and again these disruptions act like contours on a map of a round hill, and so we again see circles. On the long diagonal of the cube, the default pattern is a tiling of all three colors. The disruptions this time are a little harder to see, but they're visible. We can still detect the change in the pattern. As the cubes get smaller, patches of more complicated patterns get larger, and our eyes begin to notice those patterns and the circular disruptions in them. So that's more or less why all these circles are there. Here's a question that we haven't figured out. What's going on with the relative rates of the circular ripples at each location? The coordinate axis circles seem to ripple the slowest, while more complicated directions seem to have faster ripples. But what exactly is the rule? One final thing you may be wondering: what happens if we let the simulation run and run? Let's fast forward a bit and see. Well, the cubes keep getting smaller, and eventually we start seeing moire effects. These arise from interactions between the grid of cubes and the grid of pixels on the screen. I think that these would go away with enough sub-pixel sampling, but as it is now, eventually the moire effects overcome the pattern of circles. Alright, that's it. Thanks for watching.